Hello, my name's Ben and I should think you're here because you've seen these amazing GIFs on OpenSea or somewhere and you're wondering all about them, and this video will tell you. I'm the maker of this machine, which is what creates your GIFs. I shall tell you in another video about how they're practically created, but this video will tell you all about what they contain and unlock their mysteries. Each GIF that you come across is an entry in a star catalogue of the stars in the sky, a catalogue or a database or a list. There have been quite a lot of catalogues over the years, and this one is one I'm creating called the Peyia Star Catalogue, and the certificate you can see is generated when the entry is made. The most important thing that's created is this code here between the two red dots, and that code represents the entry in the catalogue. All this other information is to do with the particular star, which we'll have a look at perhaps later. The pulsing of the 7 lights that you can see carries the information of the catalogue entry code. Each light represents one of the binary digits of the computer ASCII code, and the combination of the particular lights carries information of a particular letter or number. This one we have here is the number 7. This one is a capital P, then we have a capital S, a capital C, a 1, a 2 and an 8, and so on. So the pulsing light is describing the text at the bottom of the GIF here. PSC for Peyia Star Catalogue, that's Peyia where I live in Cyprus at the moment. 1287 is the sequential entry in the star catalogue. BG is the initials of the sender, that's usually me. Procyon is the name of the star. Most stars have names, a lot of Arabic names, and if there isn't a name, there's the Bayer designation, which is usually a Greek letter and then abbreviation of the constellation, and then this random 16-digit code. The length of each individual frame in the GIF is half a second, with only a minimal gap in between. I did have a bigger gap of a blank black screen, but that was very hypnotizing and fascinating, and I don't want to give anybody epileptic fits or migraines, so I've just left them as they are. When a pulsed light beam is sent, we generate a certificate, and this one is for the Peyia Star Catalogue, and it just records all the information. It's recorded as a PDF, so it can be downloaded and printed, and I'm wondering whether in the future, for any owner of an NFT, whether they could have one of these certificates with their own details on as an owner. So we'll see in the community whether that's something that we could go for. The final 3 frames of the GIF are this stellarium screenshot of the star, the time and all its details. I really suggest that you get Stellarium. It's a really good app for you to locate stars, and it's got lots of other features as well. And if you do buy an NFT for a particular star, you can locate it with this, and then you will know that the light beam that you own through your NFT is flying towards that star at light speed. This is the spreadsheet version of the database, and all the information is laid out here. You can see the code, the name of the star in column C. Column D is the constellation, and then E, F, G and H columns contain other catalogues for reference, and you can see their data there. The right ascension and declination is the position in the sky, like a north, south, east, west. The visible magnitude is how bright it is as we look at it. I've limited the star catalogue to 4.4 magnitude, and that's because of the viewing conditions here in my eyes as well, and that limits the number of stars to about 12 to 1500. There's the star's absolute magnitude, its distance from us in light years, and its spectral class, which is the kind of light that it gives out. These things vary, and some are rarer than others, so incorporated in the NFT will be a rarity index based on these parameters. These are the latest entries in the Star Catalogue. Procyon is number 288 there, you can see, and that's the one we've been playing with. There are some different interesting stars or entries in the catalogue where there is a difference that I've noted, and if you look at this one 291, that's not in its proper constellation. That's actually a star that's in the wrong place, if you like. Not from me, but in the sky with its designations. And we're up to number 296 now, so there's probably another 1,000 to go. But that'll be all good fun. It's great fun doing this. And I think to finish the video, we'll go outside and have a look to see what the light beam looks like from the sender's point of view. This is the first of 3 clips. It was really difficult to get the exposure and the focus right, but luckily the moon was up in the sky, so that gives us some kind of reference. The sharp-eyed of you will notice that each code ends with a few fixed characters, and you can ask about that in Discord. The second clip, I lowered the beam to include the village, and that will give you some idea of scale and perspective again. Each of these codes that we see in the clips are of the one we've been studying for the star Procyon. The real one that's in the database will get to the star in 11 years because Procyon is 11 light years away, and that's actually quite close for a star. So in 2033 we can have a party. Only a tiny portion of the light beam will actually hit its target, and the rest of it will carry on for thousands of years if it's going towards the Milky Way, or actually, believe it or not, forever till the end of the universe if it can get out of the local galaxy. Thanks for watching this video. This video is the first of 2. The second one will be the practical aspects of the way the GIF is made, and also you can ask lots of questions in the comments down below, and on the website there's loads of information, and on various social medias you can see the icons, links in the descriptions below.